This is our video on triangles and offsets as promised. I'm not going to bore you with all the different types of triangles, um, equilateral, isosceles, scalene, acute, obtuse triangles. We don't use any of that shit. The only one we're concerned with is the right triangle. So let's work on that. Alright, here we go. Solving these triangles involves a couple different formulas that we can use, like the one we used in class. This is an alternative method for solving our triangles. Remember, we're using tangents for just about everything. It'll be a rare occasion you come across a triangle you can't solve using this method. I call it the alternative method. And I call it alternative because most of the time we are taught this method here. Okay, this is the mainstream or normal, also known as Pythagorean theorem. Pythagorean theorem, if I can freaking spell that. Pythagorean theorem. Okay, we'll be using both methods to solve the lengths of unknown sides and angles. We'll go through both for our triangles and offsets. Kind of go hand in hand. And some pretty common uses for triangles. These right triangles are used by many different trades. They're used by carpenters, surveyors, pipe fitters, hell, farmers. Even ancient Egyptians used it. One of the methods we use, like one of the special right triangles, we call it special because it's got a set length of sides. We call it the 3-4-5 triangle. It is a right triangle. And the reason the 3-4-5 is so useful, it's mostly in fabrication shops where you have a large fabrication, or using a large pipe, large bore pipe that is just too big to use a 2-foot square on to check and make sure that your legs for your fabrication are actually 90 degrees. So with the 3-4-5 triangle, that makes it easy for us. What you do is you go from center out. Okay, you measure 3 feet, and you put a mark on the top of your pipe. Then on the other leg, you measure 4 feet from center, and you put another mark. Now you would move this leg or this leg, whatever direction you need to, until this measurement from the top dead center of this pipe to top dead center of that one equals 5 feet. When you have 5 feet from there to there, and you've measured 3 foot on this leg and 4 foot on this leg, your fabrication is exactly 90 degrees. Extremely useful, like I said, for large bore pipe when you're dealing within in a fab shop type environment, and your 2-foot framing squares that we normally use to check for square just aren't big enough. Very, very useful type of triangle. Ooh, damn, that's pretty good. Tangent, opposite, adjacent. C squared equals square root of a squared plus b squared. Alright, so let's do a couple offset problems. Get our triangle up here. Right triangle. Get some pipe on here. This is a parallel offset. Okay, this is our run or advance. This is our offset. Now you can tell which side is which because the side of the triangle that runs with the pipe, okay, that is the run. If you look at this side, it does not continue, there's no continuation of the pipe, so it's not the run. So the way our fittings are measured in degrees are from the backside or the heel of our fittings. Okay, so this line being a continuous 180 degrees, we want to know how far off of 180 degrees this fitting needs to be, and whatever that is, the same will be true over here. Come off of 180 degrees by 30, then you have to go back to 180 degrees by 30. So let's get some dimensions on here. We got say 2 foot 3 inches for our run and 1 foot 6 inches for our offset. So let's figure out our angle first, okay? Since this is the angle we're looking for, again, this is the back side of our fitting, so this is the side we want to solve from. If you solve it from this side, then the opposite is true. You'd have to take whatever your degree is over here and subtract it from 90, and that would tell you what both those fittings are. But we're going to follow our rule over here. The tangent of the angle is equal to the opposite side divided by the adjacent side. So this being the opposite side, this being the adjacent side. So opposite divided by the adjacent. 1 foot 6 inches divided by 2 foot 3 inches. Okay, so let's pull up our calculator. We got 1 foot 6 inches divided by 2 feet 3 inches. Gives us a tangent of 0.667. Okay, so we have to convert that to a degree. So convert tangent. It gives us a degree of 34. Okay, so our angle is 34 degrees, and that is 34 degrees on both sides, since it's parallel. If this were perpendicular, it'd be different. You'd have to subtract 34 from 90, and that would tell you what that degree is if it were perpendicular. So we'll have to solve a takeoff. for that fitting. We've got our travel to solve. We've got our cut piece or end-to-end measurement to solve, and that should do it. So to find our takeoff, okay, our formula, if you remember in class, was the tangent of half the degree times the radius. Okay, so let's say we're dealing with 2-inch nominal pipe size. Our radius is always 1.5 times our nominal pipe size, which makes it 3 inches. If our nominal pipe size was 4 inches, our radius would be 6. 4 times 1.5 is 6. So we're going to figure out what the tangent of half the degree of 34 is. So go back to our calculator. Okay, we got 34 divided by 2 equals 17. Okay, now the tangent of 17 is 0.305. So 0.305 times 3 inches will give us our takeoff. Okay, times 3 inch equals a takeoff of 15/16. Okay, so we're going to take off of 15/16. Okay, we got 2 fittings, so that's an inch and 7/8 for total takeoff, plus a 1/4 of an inch for 2 weld gaps of 1/8 of an inch each. So now we can solve our travel. A squared plus B squared will tell us that. Okay, so 1 foot 6 inches squared plus 2 feet 3 inches squared equals, okay, and then the square root of that is 2 foot 8 7/16. 2 foot 8 7/16, center to center. So now we've got to solve our end-to-end measurement. We have all the information we need for that. Okay, we take our center to center measurement, 2 foot 8 7/16, and we're going to subtract our 1 7/8 plus a 1/4 inch. So that's 2 1/8. 2 1/8, and we're going to subtract that from 2 foot 8 7/16. So I'm going to convert this to 16ths to make it easy. Okay, that's 2/16, and now we can subtract them. Okay, we got 5/16, 6 inches, and 2 feet, and that's our end-to-end measurement. Okay, pull up our calculator. Okay, clear this out. We're working with 2-inch pipe size, and we have an offset of 1 foot 6 inch offset, 2 foot 3 inch run. Our travel is 2 foot 8 7/16. Let me slide this over so we can see what we got here. See that? 2 foot 8 7/16. We got a cut length of 2 foot 6 3/8. Okay, we got a 1/16 of an inch difference there. We're fine with that. Okay, hit travel again, our takeoff 15/16, just like we figured. Our weld gap of 1/8 of an inch each. Our fitting was 34 degrees, and that's where that 1/16 of an inch difference comes in. Right there, the difference there, that half a degree practically. And this also will give you the arc lengths for inside, center, and outside for creating that fitting. Alright, clear that out. We'll do one more. Move that over. Alright. Clear this out. Alright. Now we'll do one more. Okay. Got our little circle up here. Our alternative method. So we can continuously refer back to it, and then of course our formula for odd angle fittings. Tangent of half the degree. Now don't ever make the mistake of just doing half the tangent of the degree. It's not the same. Always split the degree first and then get the tangent. So here we go, another triangle. Okay, this is our right angle. Get some pipe on here. Okay. Alright, now this side here is a continuation. This side of our triangle is the continuation of the run of our pipe. So this side is our run. Don't make the mistake of thinking that the longest side is always going to be the run. And this side is our offset. Okay, so being that this is the corner, this is the side of the triangle that is in continuation with the run of our pipe, it means this is the angle that we're going to solve with our alternative method. Opposite over adjacent. Okay, so we'll make our run 8 inches and our offset 3 feet. Okay, so just like our formula over here, alternative method, opposite side divided by the adjacent side. So we got 3 feet divided by 8 inches. Okay. Got 3 feet divided by 8 inches. Gives us a tangent of 4.5. We need to convert that to an angle. Gives us an angle of 77 degrees. Okay. Angle 77 degrees. And we gotta get our takeoff, our travel, and our cut length or end-to-end measurement. Alright, so to get our takeoff, like before, tangent of half the degree times the radius. We'll just keep it at 2-inch nominal pipe size. So our radius is 3 inches. Tangent of half the degree. We got 77 degrees. Divide that by 2. And the tangent of that is 0.795. So I'm going to times that by 3 inches. gives us a 2 3/8. So 0.795 gives us a takeoff of 2 3/8. Okay, times that by 2 equals 4 3/4 plus our 1/4 of an inch for the 2 weld gaps gives us a total of 5-inch takeoff. So now our travel, a squared plus b squared. Our center to center measurement. Okay, so 3 feet squared plus 8 inches squared equals, now it doesn't matter which order you put those in, you're just adding them together. And the square root of that is 3 feet and 7/8 of an inch. Okay, 3 feet and 7/8 of an inch. Okay, now we can solve our end-to-end measurement or our cut length by taking our 3 feet, 0 7/8, center to center measurement, and subtracting 5 inches from it. This is our takeoffs. Okay, we got 7/8 to subtract, we got nothing to subtract from 7/8. Okay, so we're just going to bring that straight down. I'm going to borrow 12 inches from here, making that 2 feet. We're going to add 12 inches over here. 5 minus 12 is 7. And then 2 feet. That's our end-to-end measurement. 2 foot 7 7/8. Okay. Come back to our calculator. Clear it out. Got a 2-inch pipe size. Got an offset of 3 feet. 8-inch run, travel, again, okay, travel was 3 foot 0 7/8, good there. Our cut length, 2 foot 7 13/16. We're only a 1/16 of an inch difference, and that's going to come from like the 1/2 degree that we rounded off. Our takeoff was 2 7/16. I had 2 3/8. Again, it's only a 1/16 of an inch difference. 1/8 weld gap, a degree of 77, and basically a 1/2. I rounded down, and that's where we get that 1/16 of an inch difference. And our inside arc length, center arc length, and outside arc length for the fittings we would need to create for that problem. And that is offsets and triangles. I hope this helps.